Hey guys, this is part of your assignment called Proving Angle Relationships. Okay, we proved three theorems in previous videos. This linear pairs theorem, this congruent supplements theorem, and this thing called the vertical angles theorem. Vertical angles theorem. So now we're going to use those facts to do some algebra. So in 8 through 13, it says use the linear pair theorem to set up and solve an equation for x. Well, what does the linear pair theorem say? It says if two angles form a linear pair, then their measures sum to 180. Okay, so here's two angles that form a linear pair. Okay, we can just see that based on, the figure here. So we know their measures equal 180. So what we can do is we can say we can say that 4x plus 3, the measure of this angle, plus 41, the measure of this angle, equals 180. Okay, we're using this theorem to talk about a fact about these angles. If they're a linear pair, which they are based on the figure, then their measures add to 180. So this equation represents the linear pairs theorem. Okay, now all we have to do is solve for x. So first thing we would do here is combine our like terms. So 4x plus 44. Okay, then we would subtract 44 from both sides. It's using our subtraction property of equality. And then we would divide both sides by 4 using our division property of equality. And we're going to get x is equal to whatever 136 divided by 4 is. That is going to be 34. Okay? So on this page, all of these angle relationships, these are all linear pairs, right? They're two angles that when you smush them together, they basically form a straight line. Right? So these two angles together form a straight line. These two angles together form a straight line. These two angles together form a straight line. That's the case for all of them. So on this page, what you're going to do is you're going to take one of the angles and add it to the other angle, and then you're going to make it equal to 180. So 8x plus 11x plus 9 equals 180. 85 plus 11x minus 4 equals 180. 7x plus 20 plus 3x equals 180. Set those up, and you're going to solve. Now make sure you show your work, okay, in organized steps. We're practicing deductive reasoning still. You don't have to necessarily justify all these steps, but you could. I mean, I'm not going to make you do that, but I definitely should see a logical flow. Also, I don't want just the answer. This equation tells me a lot more about your understanding of this theorem than the answer. So I'm looking for these equations when I grade them. Make sure you write out your equation and then solve it. Okay. That uses the linear pair theorem. Now on the other page, the next page, we're going to use a different theorem called the vertical angles theorem. So this is a different angle relationship, which means our equations are going to be set up differently. Okay, in linear pairs, the angles sum to 180. In vertical angles, they're equal to each other, or they're congruent. So here we have two vertical angles. Okay, what does the vertical angles theorem say about vertical angles? It says that if they're vertical angles, which these are, then their measures are equal, or they're congruent. So I can just set up this equation. Okay, notice there's no 180 involved this time. You're not adding them together, you're setting them equal to each other. Okay, so this is what I want to see. I want to see your equation that shows you know what that angle relationship is, and then from there you're going to solve it. So plus 2 plus 2, 33 equals 11x. That's using the addition property of equality. Okay, then using our division property of equality, get 3 equals x. Then using our symmetric property of equality, we flip it around. Okay, now I'm not going to make you write all the justifications. Just go ahead and solve it. However, I do want to see your equation written out. Okay, all the angle pairs on this page are vertical angles. Okay, so these are vertical angles. What do you know about vertical angles? The vertical angles theorem says they're congruent. So 7x plus 4 must equal 6x plus 10. 4x plus 1 must equal 77. 9x plus 14 must equal 86. Right? So find the two angles, they're vertical angles on this page, use those expressions, set those expressions equal to each other, and then solve for x. All right, now on the last page here, you have some proofs to do, okay? But I've given you some hints. So let's talk about 20 and 21 for a second. Okay, 20 and 21 are going to be almost exactly the same as like 4 and 5, okay? The only difference between 4 and 5 and 20 and 21 is that this is congruent supplements and this is congruent complements, right? So complementary angles add to 90 degrees. So if you need some help with number 20, look at problem number 4. Okay, we want examples of the congruent complements theorem. So they're not, the angles that you're going to draw aren't going to add up to 180, they're going to add up to 90. But you're going to show that if two angles are complementary to the same angle, then they have to be congruent to each other. Okay, so use number 4 as a template, but number 4 is talking about supplementary angles, and number 20 is talking about complementary angles. Otherwise, they're the same. Okay, likewise, 21, you're going to write a flow proof, right? But that's going to be a little tricky because proofs are kind of hard. However, if you go back and you look at number 5, you have a flow proof of what this looks like. So your flow proof for number 21 is going to be almost exactly the same as this one. The only difference is it's not going to say 180, it's going to say 90, right? Because complementary angles add up to 90, not 180. All right, so use 4 and 5 as a template to help you get 20 and 21. Very, very similar. The only difference is in 20 and 21, we're talking about angles that add to 90 instead of angles that add to 180. Okay? All right, in 22, you're going to write a proof of the vertical angles theorem, a flow proof. Okay, now the nice thing is I've already given you the proof of the vertical angles theorem in the 2-column form, right? So we got this theorem right here. Okay, this is the vertical angles theorem. It's already there. All we have to do is we have to just convert it to a flow proof. So you already got all the statements, you already got all the justifications. Okay, I'm going to help you set it up and get started, and then you can go from there. Okay? So let's draw a representative figure again. So we'll draw two intersecting lines. I'm going to call this angle 1, angle 3, and angle 2. Okay, given angle 1 and angle 3 are vertical angles, prove that angle 1 is congruent to angle 3. Okay, so we start off with a kind of a single box here. Okay, so angle 1 and angle 3 are vertical angles given. Okay, now from there what happens is we kind of split off into two different pathways, because now there's these two groups of angles that we're going to talk about, this pair, and there's this pair. So we're going to have kind of parallel statements for those two angle pairs, right? So we know angle 1 and angle 2 are a linear pair based on the fact that 1 and 3 are vertical angles, right? If we have 1 and 3 vertical angles, then we know we're going to have these other angles involved that are in between them. And so that's kind of where angle 2 is. So building off of this fact, this figure that we built, we're going to get the linear pairs. Okay, angle 2 and angle 3 are a linear pair. Okay, now again, the I guess spatial orientation of your flow proof, it doesn't have to go left to right. Okay, you can kind of put the boxes wherever as long as the arrows are going in the right direction. So some people like to go top to bottom, whatever. Just whatever you have space for. Okay. Now this guy here, we're going to say angle 1 plus measure of angle 2. Sorry, measure of angle 1 plus measure of angle 2 equals 180. Measure of angle 2 plus measure of angle 3 equals 180. Okay, now I didn't write my justifications for all these. I'm going to leave that for you. So these need to have a justification. You should write it underneath. And these should have a justification as well. So write them underneath. Okay, if you're confused, you can go back and look at your vertical angles proof that we did, right? All your reasons are over here. But notice since I have like two sets here, that's kind of where I'm splitting up my pathway. Okay, but then these pathways are going to converge again. They're going to come back together. because I'm going to write one equation. I'm going to use a substitution, and I'm going to set some stuff equal to each other like we did in the other one. So these pathways are going to come back together, and then we're going to have a couple more ideas here to finish it out. Okay, so that'll get you started, but again, you already have the full proof. This is just kind of helping you with the flow structure. So use the proofs that we've already done to help you with 20, 21, and 22. You already have the reasoning. You just need to kind of practice the structure. Okay? Hope that helps. Thanks, guys.